Let's solve a problem from Newton's mechanics. An object of mass 10 grams, and I'm reading the problem and I'm also writing the information that is given, is thrown upward with 20 meters per second initial velocity, and then it falls under the force of gravity. If air resistance is 10 V, find the equation of motion at time t. If the object is 400 meters above the ground, when will it hit the ground? Okay, so the very first thing that I want to do is decide the direction of motion, and I'm going to say downwards because it falls under the force of gravity. So direction of motion. Now I have this object above the ground, like 400 meters above the ground, and the force that acts on the object is the force of gravity, so which is mg. Then the air resistance, which is opposite to the direction of motion, is 10 V, so I'm going to put minus 10 V because it's opposite to the direction of motion. And I also have that initial velocity, which is going upward, so basically it's going against the direction of motion, so that's why we put minus, because it goes upwards. If it went downwards, it would be 20 meters per second. So let's solve the problem. Newton's second law says F equals m times a. So all the forces that act on the object are mg minus 10v equals m times a. So let's substitute what we know. So I have 10g. So just to be clear, this is grams, and this g is 9.81 meters per second squared. Minus 10v equals 10 grams times acceleration, which I can write dv dt is the derivative of the velocity with respect to time. I can divide everything by 10 to simplify my computations, and I get this nice equation. It seems like I write v's two different ways, but it's the same v. And this equation, if I replace g with 9.81 just to emphasize the fact that it's a constant, I notice that this equation, it's first order differential equation. I can look at it as a linear and solve it as a linear equation, or I can say it's separable, which will make solve my problem much easier. So that means dv over 9.81 minus v equals dt. We integrate both sides. So if we differentiate the denominator, we notice that we'll get minus dv. So I'm going to put that minus in front of the dv and in front of the integral, which is going to give me negative ln of absolute value of 9.81 minus v. If this trick that I used here, it's hard to understand, feel free to solve the left-hand side by substitution. Equals t plus c. I'm going to multiply by negative 1, and ln of absolute value of 9.81 minus v equals negative t plus c. We raise e to every single term, so we get 9.81 minus v equals c e to negative t. So velocity, v of t, equals 9.81 minus c e to negative t. We know that the initial velocity, v of 0, equals negative 20. Let me check that again. Yes. So if we set v of t equal to 0 in this equation, we get 9.81 minus c equals negative 20. So c equals 29.81. So the velocity at any time t is 9.81 minus 29.81 e to negative t. From this, and I'm going to put this in a box, important, I'm going to refer to it. From here, we can find x of t. We know that the derivative of the position function with respect to time gives us the velocity, so x of t will be the integral of v of t dt. So when we calculate the integral of 9.81 minus 29.81 e to negative t dt, we're going to get 9.81 t minus 29.81 e to negative t over negative 1, so this becomes plus some constant. So since we consider x of 0 to be a 0, like at time 0 it didn't move at all, we have 29.81 plus c equals 0, so c equals negative 29.81. So x of t, the position function, is 9.81t plus 29.81 e to negative t minus 29.81. So to answer the question, the second question, if the object is 400 meters above the ground, when will it hit the ground? We set x of t equals to 400 and we solve for t. So we get 9.81t plus 29.81 e to negative t minus 29.81 equals 400. So 9.81t plus this term, we'll consider it, we'll just remove it, we'll consider it negligible. Just take t equal 10 and you're going to see that you get a very small number like 0.001 or something like that, which in terms of time it's negligible. And then equals 429.81. So t equals 43.81. The time was measured in seconds, so seconds, and I rounded my answer to 2 decimal points. I hope this helps.